welcome you all for this exclusive session and Masterclass webinar series titled Challenges in the Journey of Digital Transformation in Manufacturing. The session is organized under the aegis of Industry 4.0 Expert Committee, chaired by Mr. A.N. Chandramouli, who is the past president of BCIC, and co-chaired by Mr. Jagannath, who is the business head of M2 Next, a BFW subsidiary. On behalf of Bangalore Chamber of Industry and Commerce, we express our sincere thanks to Mr. Gautam Datta, who is the consultant of Siemens Digital Industries Software India, for accepting our invitation to address at this session. Thank you very much, sir, for accepting our invitation. I now request Mr. A.N. Chandramouli, sir, to take it over from here. Over to you, sir.
Thank you. Thank you. Are you unsharing your file?
Yes, sir. Just 2 minutes. Sir, I would like to acknowledge our annual sponsors for the events, our member organizations, Mrs. Bueller, Fundramax, MTR, Sona Group, and Wipro Technologies for their annual sponsorship for the events. Now over to you, sir. Please take it over from here. Thank you, sir.
Thank you. Thank you. Thank you. Am I audible, Rupa?
Clear, sir.
Is my first screen visible?
Not yet, sir.
Oh, because you shared, then it went off. Okay. How about now?
It's visible, sir, now.
If I move it, my second screen is coming?
Yes, sir.
Okay, good morning to all, one and all. Good morning, Mr. Gautam. Good morning, Rupa. I think more people are joining. As usual, it will happen during my inaugural address. And this year, from January, we started a Industry 4.0 Masterclass webinar series. Of course, the journey is going on for the last 2 years. And thanks to COVID, we had crossed even around 30 webinars under Industry 4.0 committee. And today we have a great leader and speaker with practical experience on the areas of digital transformation in manufacturing. And with his own experience in the several decades of working in Siemens, he will share with us the challenges. I'm sorry, there is a noise on my background, but since I will log out in 15 minutes, you will not have this noise. I will not log out, but I'll switch off my audio. So let me move on with a few remarks on the background. Last month, NASSCOM and Capgemini came out with a report which is titled as India Industry 4.0 Adoption by 2025, which is post-COVID report. So this is the latest of its kind. It's, I think, around 100-page report. And it outlines the importance of skill building apart from technology areas for meeting emerging job demands based on Industry 4.0 globally as well as in India. The primary focus of the survey was in India, and Indian manufacturing has spent around $6 billion on Industry 4.0 last year. Financial year 2021 ending March 2022 has spent $6 billion on Industry 4.0. Very delightful information gathered by Capgemini and NASSCOM, of which 50% is spent on the 4.0 technologies, and a small fraction, it only represents a very small fraction of the total. And in that, around 50% is on foundational technologies like cloud and IoT, and another 35 to 40% on other technologies, which I'll touch upon. And they're going through proof of concept stage, and then very soon they'll go into the implementation phase. And 75% of the total spend is in the discrete manufacturing, automobile, electrical industry, electronic industry, etc. And 25% is on chemicals, pharma, and other areas, which is a non-discrete manufacturing. Let me move on. Today's webinar context by Mr. Gautam Datta is to emphasize digital technologies playing a crucial role in enabling manufacturing companies, especially small and medium enterprises, to respond to the dynamics of the new normal. Underline the word dynamics. which Gautam will explain the dynamics. While the digitalization benefits of cost, time, quality, flexibility, and efficiency remain unchanged, the priorities are changing. Post the pandemic COVID-19, organizations are looking at digitalization with refreshed focus to improve their agility, to respond to fluctuating market dynamics, and achieve operational flexibility. Again, the key word here is flexibility. Earlier I said dynamics. To produce diverse products, variety of products in smaller volumes, and to be operationally transparent when managing production remotely. You should be able to even manage operation when you are doing remote monitoring. Thanks to COVID, many remote monitoring tools have been used. Sorry about the noise in my background. I'll finish very fast. Today, the speaker profile, Mr. Gautam Datta, is a consultant to Siemens Digital Industries Software India, but he himself worked in Siemens for more than 3 decades, started as a CAD/CAM engineer and then on and on and on, then PLM, and then implementing digital factories for his own company divisions as well as for customers. He spent more than 4 decades in the PLM industries, and in the last decade in IoT driven PLM. ANSYS, PTC, IBM, TCS and HAL, these are some of the names other than Siemens. He has guided many manufacturing organizations. I myself attended his workshop on behalf of CII, and that is where I first came to know him. Very practical workshop where even I was a trainee. That was around 4 or 5 years back. And implementation of digital transformation is his strength. Not only theory and concepts, but actual implementation. His special area of interest is extending it to across various sectors of manufacturing. He is alumnus of Delhi College of Engineering, IIT Madras. He is passionate about his profession and contributes to the improvement of engineering practices in India and also other countries. Right now, he is pursuing his PhD. Maybe he will give us a good news whether he already became a doctor. Gautam is pursuing PhD in Amity University in Delhi. And on that note, I would like to briefly touch upon. He will say, hello? Hello? The 5 takeaways from Gautam's session. We look forward to eagerly about these 5 takeaways. Holistic view of digitalization. It's not some point solutions being implemented in some parts of the function or some parts of the organization. Number 2 is value chain imperative. The focus is on entire value chain from design to after sales service and across the supply chain, including tier 3, tier 2, tier 1 and OEMs. Priorities are extremely important. You can't go after all the solutions simultaneously. And to see whether the industries are ready to adopt. Different companies are in different status of adoption. Different sectors are in different status of adoption. The adoption has been accelerated by COVID. So he will address the challenges and way forward. Thank you very much, Gautam, for accepting. I will unshare now and leave it to you to take over. I think we all have learned time management. I was supposed to stop at 11:15. I think I stopped at 11:12. Thank you, Gautam. Over to you. And at the end of Gautam's session, we will be having a powerful question answer based on the text box comments written by all the audience. And already I see around 45-50 people have joined. And I'm sure by 11:30, we will cross the century mark. Thank you very much. Go ahead, Mr. Gautam.
Thank you. Can you hear me?
Yes, we can hear you loud and clear.
So tell me that you can see the screen.
Perfect. We can see the first screen, challenges.
And I hope you can see me too a bit.
Whoa! That is a trick you must teach me later. Right. I didn't have that tool. Okay.
That's part of Teams. It's okay. I mean,
Wow.
That's really standard.
Wow. Okay. Let me try the next time. Yeah.
Yeah. So you can see the screen properly. So that
I can see the screen.
Thank you very much.
See you.
Thank you and welcome to today's session. As Mr. Chandramouli said, that we have takeaways, we have the complete holistic understanding, but I thought I'll flip it around because most of us, we are aware of what kind of initiatives can be taken individually by many companies.
Gautam, maybe you can little louder, please.
Okay. Can you hear me now? Proper?
Yeah.
Louder? Okay. So what I thought was that I will flip it around and make the challenges first. And we discuss the challenges. And I would like to make a comment upfront that there are words that we use blurred between their meanings, like smart manufacturing, like industry 4.0, like digitalization or digital adoption. Essentially, they all mean the same as far as this session is concerned. I may be flipping between these three words, but essentially means the same, that considering the market challenges that we are facing, which we will discuss, how are
Sir,
we going
sorry to
to?
interrupt, sir.
Yeah, tell me.
Your screen is not visible. It has become dark now.
Okay, that's what I asked. Okay, let me share it again. Can you see it now?
Now it's visible, sir.
Okay.
No, Rupa, I can see it even when Gautam came on the screen.
No,
You may
only
be having,
his picture was visible, sir. The screen background was blank.
Can you see it now?
Yes, sir. We can see it now, sir.
I just, yes, now you should be able to see it now because I can also see it.
How about now?
Thank you.
Rupa, how is it now?
Sir, the screen is visible now, sir.
Okay.
Okay. Another trick on trick. Okay, go ahead.
Okay, so what I would do is I'll start with the challenges, and as I said, the words are blurred, but it all means the same. How do we adopt digital technologies to be able to face the market challenges as we know we move forward in this new era of post-pandemic? What is the meaning of digitalization in manufacturing? This is not my definition. I've taken a definition from Forbes, which I liked, that smart manufacturing is the integration of intelligence in machines, parts, materials, products, buildings, supply chain, everything put together. And idea is that with smart manufacturing, data is the master, no longer the system. So this is probably the first challenge that we would face as companies adopt data as the basis of decision making and not gut feel, not experience only. They would probably be dependent upon day-to-day data that we get from IoT as we are experiencing. What is the difference? The difference is many a times we believe that what we have been doing for last many years is the best way of doing it, whereas data may show it differently. And when data comes to us, which is contrary to the way we used to practice, it challenges us. So that's why I call it a challenge. What is essentially a smart manufacturing concept? I think it is important that we discuss that for a moment. Of course, we have smart machines, smart products, smart logistics, and then we have integrated open IT-based systems that bring all these together. But essentially, when I am saying smart, I mean that there are areas, there are functions in my manufacturing setup where the physical phenomena is connected with a digital setup which is collecting continuously data, and the physical phenomena of machines are such that the machines are connected to each other, connected to the product it is making. So essentially, whatever I do, wherever I may be collecting customer data, I may be designing, I may be confirming the design with the customer, I may be making a process plan, I may be confirming the process plan with the manufacturing shop floor, I may be manufacturing, I may be making the tool, I may be testing, and then after we have supplied it to the customer, the customer is using it and I'm getting continuous performance data. If you imagine these physical phenomena connected with a digital layer, which is collecting continuously data that I'm getting in an intelligent form, and I'm able to take decisions, I'm able to take quick decisions and informed decisions, that is smart. And that is what we believe is going to not just reduce the time taken to make decisions, it is going to allow me more accurate decisions, because now I have a basis of taking those decisions, day-to-day decisions. I also have ability to access past knowledge of the organization. Therefore, it gives me the reuse capability. And when I reuse past data, past knowledge, it reduces time to take decisions. It reduces time to market. So if you see now, what I'm basically coming to is because of the smart ways of doing things, we are able to impact all the cost, time, quality imperatives. My quick decision, rapid decision, and the accurate decision making and reusing of our past knowledge all put together gives me these imperatives. So that's the reason why smart manufacturing is becoming something that people are looking at. And as Mauli said, that 50% of many of companies have started some kind of work, many of them on POC, and they are starting work primarily from IoT. This is a very interesting aspect. When I did my own research among the Indian companies, I asked a question. Would you like to have digitalization implemented in design first, so that you can digitally make the design, or simulation so that you can validate the design, or simulate the manufacturing plan so that you know that whatever you're doing, you're doing it first time right, or you're going to monitor your performance of your product or in the shop floor? The answer came back on monitoring first. And I'm not surprised when Mauli said that IoT and cloud are the first decisions that the companies are taking, because more and more companies want to take database decisions. So that's not a surprise, but that we will discuss as we move forward. So I hope I made some clarity on what do I mean by smart, and now I bring the history and how we are moving forward towards future. Although this slide shows 4 boxes on x-axis of automation and y-axis of flexibility. If you start with pre-third industrial revolution, Second World War, before Second World War, during Second World War time, you're looking at the bottom left box, which is the fixed and manual. Then we moved towards more engineer to order classic manufacturing execution. That is, you moved on flexibility, but automation was low, which is flexible and manual, essentially engineered to order. There is one box which is called it fixed and automated, which is made to stock, which is what essentially we have been doing for last 10-15 years. Okay, where we have a traditional customer base, we have a traditional supplier base, we know how many parts or products we have to make, and we make to stock. Classic automation, robots, PLCs, all that comes together to make it fixed and automated. There's one box missing here because I could only show 4, which is also, I may call it flexible and automated. This is what Mauli alluded to when he was reading the objective for today. That is mixed model, small batch, agile. This is the current business thinking. Okay, just a moment. This is the current business thinking. And where we are going is flexible and autonomous. High on automation, high on flexibility. This is the future. But I believe that unless we take the step of flexible and automated, it'll be challenging for us to go to flexible and autonomous. So I hope I could put together a perspective of time here, that we started 60, 70 years ago on fixed and manual, and right now, currently, we are aspiring to become flexible and automated, which means small batches, mixed models. From the same shop floor, I should be able to make multiple models without adding cost with smaller batch sizes, which is what flexible manufacturing is, and which is what connects us to the market need of mass customization. I'm sure you have heard this word called mass customization. It would mean that my need of something is different from your need, and a manufacturer should be able to fulfill both our needs without adding cost. And that is what mass customize helps us to do. And that is what flexible and automated setup helps us to achieve. And we are going towards flexible and autonomous. You can hold your questions. I will take a logical stop somewhere and ask you to ask me questions in between, and then we can move forward. Now, what are the barriers we are facing today when we are moving from this fixed and automated to flexible and automated? There are these barriers. Now, why am I saying these barriers are important? These barriers are beyond the traditional barriers that we have been reading in the research papers for last 4 or 5 years about readiness, skill building, availability of funds, infrastructure, logistics, government policies, etc., etc. These are, of course, these are important barriers. But today's session, I thought I would take more implementation barriers, because we know those barriers exist and a lot of people have been discussing that. I'm touching upon pure manufacturing engineering barriers and how do we address those barriers. So those I call readiness barriers. I'm not touching on that. I'm talking about implementation barriers or post-implementation barriers. It is best to forecast these post-implementation barriers in advance so that we don't face these problems once you have invested, started to work, and then you realize, oh, I just moved the bottleneck. I use an example that a lot of people who are from Gurgaon and Delhi would have faced 10 years ago when Gurgaon highway was being made. A beautiful highway was made. A lot of vehicles went on high speed to travel from Delhi onto Gurgaon and beyond, without realizing that that highway has created bottlenecks below the flyover. With all the entry and exit points, they were not managed, so bottleneck got shifted. We can't achieve digitalization by shifting bottleneck. This is exactly what happens when I implement, let's say, digital design in CAD, and you're making all these very nice, fast designs, making them available, releasing the bill of material, but that's getting stuck because in manufacturing planning, they are using traditional way of developing process plans. Unless the process planning is also digitalized, the bottleneck would be process planning. Let's say process planning becomes digital, then the bottleneck becomes shop floor because they are traditionally using their own way of doing it, and these bottlenecks shift. And this is where I would bring in the aspect of a holistic view, and that's why I want your attention towards what is drawn at the bottom of this slide. Let me change my pointer. So can you see my screen, Rupa, and the pointer? Just give
Yes,
me a
sir.
check.
Visible,
Yeah,
sir.
thank you. Yeah, thank you. So I have a customer requirement. I do design and engineering. Then I do manufacturing engineering, which includes process planning, tool planning, resource planning, everything. Then actual production on the shop floor. And then I deliver the product to my customer and I start servicing. And this is where the performance comes in. I want to highlight something very important. There are two layers on which digitalization is working here. One is on my shop floor, and one is in the product that I'm selling. Let's say I'm making a motor, electric motor. It's an IoT ready electric motor, and all my entire shop floor is connected, and I have uh, data collection, data acquisition strategy in place, and I have IoT ready devices everywhere, both from quality or manufacturing. Remember, there are two layers working now. I'm collecting data on my shop floor, which gives me the operational view. and I'm collecting data from the product that I sell to the market, that gives me the performance view of the product. Let's not mix the two. These are two separate things. Okay, but both are important. And when I am talking digitalization, I mean both digitalization of the process and digitalization of the product. Now let's look at the barriers. I've tried to make these barriers available to you to see on a single slide so that we can get a holistic view of this. First barrier would be a fragmented digital infrastructure with a lack of integration between supply chain, manufacturing, and production. This is the first barrier, which I just explained when I said the bottleneck moves. The second is ineffective closed loop without a continuous improvement along the manufacturing value chain. I'll give you an example. In my life, last about 3 years ago, I met a gentleman in one of the exhibition. He said, here is my mobile phone and I'm getting continuous data from my shop floor as to which machine is doing what. Agreed. Good thing. Very good. But what are you going to do about it? That's what I mean by ineffective closed loop. You're getting a feedback, but you're not doing anything about it. It stays as data on your phone. It comes as data as input unless there are activities which are part of the process, that if there is, let's say, a feedback coming from the shop floor that two machines which should be performing at 95% utilization, making, let's say, 200 parts an hour, are making 180 parts and utilization is 80%, there has to be a threshold action that gets kick-started, a corrective action, a continuous improvement action, which is the mainstay of smart manufacturing, a closed loop continuous improvement. Next, normally, most of our processes that we adopt and therefore digitalize point at a single purpose inflexible linear process. That won't do, because we already decided, we already agreed that the market dynamics is making me look at making myself flexible so that I can switch between one component to the other, one product to the other, from one batch to the other, reducing the changeover times, reducing the wasteful effort that we make on the shop floor. How do I make it smooth? How do I ensure that in the morning of the day when I decided I will make 100 of A part and 200 of B part, an order comes and says, no, 100 has to be 50 and the 200 has to be 300. I should be able to switch quickly with still not losing my utilization and operational efficiency. That is what is single purpose inflexible linear process as a barrier. Then ineffective transformation of raw data into actionable information. This is what again alludes to that example which I said, oh, here is my mobile phone, I'm getting all the data. But unless the data is contextualized, it remains ineffective. Unless the data says this is from shop floor A, machine 1, this is from machine 5, this is from machine 10, this is a quality feedback, this is a manufacturing feedback, this is a heat treatment feedback. Unless it is contextualized, I neither can take action intelligently, nor that data is of any use in the future for me, because I need to store these data. The data has to become information. Information has to become knowledge. The knowledge base would give me the power of creating autonomous algorithms in the future. That's why I said it is, yeah, unless we fix our automated and flexible today, it will be very difficult and challenging for us to get an autonomous and flexible tomorrow. I'll repeat, unless we fix our automated and flexible today, it will be challenging for us to get an autonomous and flexible tomorrow. All the AI aspirations that we have, machine learning aspirations that we have, is based on learning. As the word goes, learning is knowledge. Knowledge means I have to structure my data, contextualize my data, and make it intelligently available to me so that I can use it and reuse it later as knowledge for better business sense in the future. Last but not the least is the sharing of the data that I am getting and acquiring. Inefficient production data sharing with lack of real-time analysis. That is where I call it the holy trinity. IoT, big data, and cloud. These three go hand in hand. Okay, these are three things that come together. IoT helps me to acquire data and contextualize it. Cloud helps me to store it and analyze it. Sorry, big data allows me to structure it and analyze it, and cloud helps me to store it and make sure that I disseminate it to the right people. This was a very critical slide for me to explain. Now I would move forward solving these challenges. Let's look at how do we solve it. Imagine, now this is an aspirational slide. Imagine if I have a cross-department integration, I have operations orchestration. That means when I make 10 in machine A, I can make 10 or whatever. I have a strategy to make 10 in the machine B so that I have orchestration. Sorry. I do data contextualization. I can make effective closed loops and I have connection to cloud. What if I can do all these? That is how I can face and mitigate the challenges of implementing smart manufacturing. These aspects I would recommend that we should take up while we are implementing and not wait for the implementation to complete, because that's when these challenges become start to hurt us. And that's where, if it continues to hurt us, our management, our investors start losing confidence in our commitment towards continuing digitalization. Okay. I will take, before I move forward, I will take a small 2-3 minutes break. Molly, if you have a question, if anybody has a question, if you think that I need to clarify something more, because it will get clarified. I have detailed example now on all these 5 pieces. Is there any question? You think I'm clear? I'm taking just a break here to ask you. I should not be going too fast. Molly? Anybody?
Yeah, I think the pace is perfect. All good. Maybe I don't know whether my computer is a problem, that your volume could be better.
Okay. Let me volume. You have told me this in the,
because you're making some very impactful points. If you can have a powerful volume, then
just 1 minute. Let me see if I can.
Maybe my computer, I don't know. Others are.
Let me see if I can put the device settings and.
Yeah, it looks better. It's slowly increasing.
Microphone. Just to give me a moment.
अच्छा है, अभी आवाज better है.
Can you hear me now? Better?
Much
Louder?
better. Much
Yep.
better.
Okay. So I think we will keep it at that and tell me that you can see me.
Yeah.
Okay. Can you see the screen?
Yeah. You're still there on the screen itself. Only the bottom of the screen.
Everything clear?
I think you don't like production. You're hiding the production. That's okay.
No, I'm
lighter
not
side.
hiding. Oh, that's
That's okay. That's a lighter side.
okay.
The box called production is hidden by you. That's okay.
Okay. That will not work. It will not be a problem now because there's nothing.
No, not at all a problem. Most of us don't like production. Go ahead.
But that is the real one, by the way. That is
Just
where
joking.
the challenges
I'm
are.
joking.
Not production has been so I would say opaque, that we have always thought, if I do a good design, if I do everything well, but real issue is in shop floor, and real growth is also the real.
To be honest, I love production.
Yeah.
To be honest,
Okay.
I love production. Go ahead.
So basically, one of the unique understanding that I would like to bring on the table is, when we are talking smart, is when we do, and everything is about closed loop. When we do virtual product and we do a virtual production, I do a verification, as you can see here. Let me again change my pointer so that. So whatever I design, I validate. And this closed loop gives me the confidence that whatever I have designed is manufacturable. I have the tooling, and whatever I manufacture will come out first time right. All in virtual. So this is what I call as digital twin of product. This is what is digital twin of production. And once I have the digital twin of production, I start manufacturing. Again, there is a closed loop. Whatever I validated here, is that really being made? Is it really happening? So this is another closed loop. Then I launch the product and I start tracking its performance. If you put all the three together, this is the complete value chain for a manufacturer. And this is where digital twin of the product and digital twin of production and performance combine to make things happen like this. And that's what gives us an ideal delivery. This is conceptual. What I have done is I will complete this first half of this today's session with the challenges and then allow you to ask me question. And then I have a real life example. I'll try and show as much as maybe a few of you would have seen it earlier. I'll show you a real example to take you through how it is getting sorted when digital twin of product production and performance comes together.
Gautam,
Yeah.
I think those who have before Windows 10 have a difficulty in seeing the screen as Rupa had. And
Why?
there are a couple of more people who have written that they are not able to see the screen. You have to revert back to your photo coming to the gallery, the conventional way,
I didn't
so
get
that
this.
they can see the screen. I think they must be having Windows 7, Windows 10 like that.
But that should not really matter.
Yeah. They are not able to see the screen.
Are you able to see now?
No, I can't. I am able to see, but the two people, Rakesh Gupta and Rajendra, cannot see. And maybe there are more people.
Okay, I will start again. I will start sharing again. Tell me
What you
those
can
gentlemen.
do, like I am on the gallery, your photo can go to the gallery.
I
The
am
conventional.
not
Yeah,
chosen my photo at all.
Now perfect. Now you are in the gallery. So I think they all can see. It depends on the what system they have right now.
Normally it should not matter, Molly.
I
Anyway,
know.
now can you see?
I was able to see then. I am able to see now because of my new computer.
No, but I'm
And
It's
now,
asking.
visible, sir.
Yeah, okay.
now
Thank you.
perfect.
Visible.
You
Okay.
can go back to the slide that you had.
Yeah, this is it. This was
Okay. All the best. I think
okay.
no one can complain now.
Thank you.
Bye.
So for a moment, my suggestion is forget the software and hardware and all this. Conceptually, it is important for us to understand, and that is what I thought we will discuss, that it is the smart way of doing work would entail whatever I do, whatever I design, I validate. Whatever I plan for manufacturing, I validate. Whatever, let's say, schedules I make, I validate by actually running a simulated schedule. And it tells me that, yes, I plan to make 150, I made 150. I made 150 of A, I made 250 of B. And that is what I plan to make. And that utilization was whatever, 90%, 95%. And I will come to some of the measurements as we move forward. So this fundamental is extremely important because this helps us to plan what we want. This helps us to identify the gap in our current processes. And then it helps us, once I have the gap, it helps us to identify which digital technology is going to fill up the gap, essentially. Because we are talking about many, many pieces. And we cannot have many balls in the air. It becomes very difficult to manage it. And I am very glad to see that report that you shared, Mauli, from Capgemini and NASCOM, which said that people are started with IoT and cloud because that is where one has to harness the closed loop data analytics and informed database decision making culture. Let me take the first challenge. The first challenge is integration. And this is just a quick example of how a machine in digital form is getting commissioned. Imagine what I mean by commission here. Today's machines, let's say I'm manufacturing machine, I'm supplying a machine. Today's machine is not just a combination of mechanical devices. It has electronics, PLCs, software, all of that put together. And it has to do specifically what the customer has given it as an order to me. So there needs to be a way of testing it, putting the PLCs, the software, the hardware, the electronics part, the mechanical part, all of that put together. It gives me a power to test it, virtually commission it even before I actually supply it to the customer. This is essentially an aerospace uh, work center. You can see all the jigs, the clamps, the PLCs, the robots, the welding robots, all of that combined. And we are able to simulate what I'm showing you right now is a real life output of the screen. The point I'm trying to make, it doesn't matter whether we're making an aircraft or we are making a motor. Eventually, if there is automation of my shop floor, I need to validate it, or there is an automation on my product, let's say a machine tool, I need to validate it before I either start my manufacturing or before I supply it to the customer, as the case may be. As I said, there are two layers here. My shop floor is one layer, my product is another, and both of them are getting digitalized. So that's the first challenge and how it is mitigated, which is collaborative design and manufacturing. The next one is, how do I create orchestrated operations? There are production schedules, and these production schedules are a function of whatever ERP has given us as an order to be delivered from my shop floor. But these schedules are not always adhered to, and these schedules are subject to many changes in supplies, in last minute orders, rush orders, rejections, reworks. My shop floor has to be flexible enough to redo my schedules as the constraints come to me. And then I optimize to maximize my utilization and output. This is the second way of orchestrating operations, by ensuring that my schedules are automated, my processes are flexible, because I can have diverse models being made from the same shop floor. Do not mind, this model could be a car, it could be a motor, it could be components of 20 different, let's say I make starter motors. I may be making starter motors for 20 brands, and each of the models are different. Each of the bill of materials are different. Each of their orders are different, and therefore each of the dynamics are different. I need to ensure that I maximize my output and my profitability, and my brand image remains by giving high quality output. This is a very interesting example. This is probably the future. Not many, few of the branded companies globally have adopted and are making use of AGVs, where AGVs deliver the raw material on the workstation. This is a real picture of the brand. I don't want to name the brand, but you can probably guess looking at the logo. Um, the AGVs first do the milk run by delivering the raw material on the shop floor, and then that follows with that model which is to be made on that workstation. Totally flexible and autonomous based on that day's orders. Very interesting example. This is real life example. This is happening in few, but this is going to be the future, whether it is cars or whether it is motors or generators or refrigerators or whatever the shop floor may be manufactured. Just in time, just in sequence, maximizing everything around customer. Customer centricity is becoming a very important aspect of modern day manufacturers. What does customer centricity mean? All the decisions that we take are targeted at the customer. That means customer requirements drive the processes, customer requirements drive the selection of what we have to do on the shop floor, and there has to be a constant, as I said, closed loop to revalidate that what I designed is what the customer required, what I manufactured is what the customer ordered, what I delivered. So if you see as designed, as manufactured, as delivered, all of them have to be based on what the customer asked for originally in his order to us. I'll give you a real life example. This happened about 7 years ago in one of uh, the seminars. We had a CEO on the panel, many others, along with many others. This was on the sideline of Auto Expo in 5, 6 years ago. And there was this question: what are the top 3 challenges as OEM you're facing? I will not name, that's not important. He answered, one of them was, you won't believe how many times I get suppliers coming to me and requesting me to accept the batches that they have supplied to us because of the deviations they had from the specs and the orders that we had placed. And that is not acceptable to an OEM. Think about it. Next is closed looping between the virtual and real. Now, this is the key to smart manufacturing. We just discussed that there has to be a closed loop between what I designed and what I'm manufacturing. That means I designed in the design office, I manufactured on shop floor, I have my sensors, I have my data, IIoT data coming to me from the shop floor, and I continuously compare the IoT data with what I designed and what I aspired. And that closed loop gives me the result of deviations. And this is the key. Whoever, again, this is research. I'm just sharing something with you. Those companies, small, medium, large, those companies which started digitalization before COVID, today say that despite having all the challenges of COVID, they came out better than they would have if they did not have digitalization. That was observation 1. This is a McKinsey report I'm quoting. Number 2, many of our small and medium businesses today are, because of the success of early adopters, are looking at digitalization as the vehicle to become more meaningful and relevant in the global manufacturing world. I will be, of course, I'll show you a real life example, as I promised, once I've gone through these challenges and how do we meet the mitigation. Next, a continuous quality feedback loop, which sets the basis for quality excellence. Quality is not an afterthought anymore. We all know that, how important it is. That means quality has to get digitally integrated with the rest of the stuff that we do. Quality is not just documentation or completing certain documentation. If I have to do a design change or product improvement, I have to do an integrated FMEA. And I have to validate my FMEA before I start. So there'll be multiple projects under that. My entire APQP process has to get integrated. And it gives me a constant feedback, allowing me, for the very purpose why FMEA and APQP is there, which is continuous improvement. This is not just collecting data from quality equipment, from inspection machines. This is about making sure that I run multiple projects. I validate what those projects are supposed to do in terms of either the product improvement or a new product development. And then I implement the process plans and the control plans that I have validated in the simulated world on the shop floor, and make sure that there is a closed loop, which gives me a comparison between what I planned and what is happening. Gaining visibility into the production data through IoT manufacturing intelligence. This is how some companies are actually looking at data, both on mobile or on shop floor panels. There is continuous insight, actionable insights gained from analysis of real-time operational data by work orders, by availability, by performance, so that you can track overall effectiveness, OEE, which is a very important measure for most of our manufacturing organizations. How many times has it happened with us that we have gone either within our companies to the CEO seeking approval for investment, or we have gone to our customers seeking approval for digital investments? First thing that most of the CEOs, business head asks us, fine, what is going to be my improvement of? And unless I track, I always give an example of when we go to a doctor and go through our annual tests. There is a 20-page report that I carry, and there are multiple actions that came out. High cholesterol, start walking, stop red meat, start exercising. These are the closed loop actions. And then when I start exercising, I continue to measure these, and unless there is an improvement, there is no point in those tests and exercises, right? So this is how it is. So activating smart decision making processes with the KPIs that I collect continuously. So the choice of KPIs connected with customer centric decision making, and my smart decision making gives me the closed loop capability of ensuring that I'm actually doing the right things and improving both the profitability and customer satisfaction on the other side. So bringing it back, essentially, this is what we discussed just now, the 6 challenges, from closed loop, contextualization, integrated design to manufacturing, effective data sharing. All these combined to give this conceptual look of smart manufacturing the way we have tried to put it on the screen in front of you. Virtual product, virtual production, and real product, all of them integrating between the virtual world and the physical world. And that is how smart is implemented. What I would do is I will stop here for a moment, and we will take 5-6 minutes. Any questions? Because now what I'm going to do in the next, we are 1 hour past, right, Mauli? Nearly 55 minutes.
Yeah, we are just about that interval time.
Yeah. So
there are some questions have come up. Would you like to take up those questions?
Yes. Why not? Why not, sir?
Great.
How do I get them?
I'm reading out from the text box.
Okay.
On your behalf.
Thank
Mr.
you,
Govardhan is asking.
Right.
Effective closed loop means automated correction.
Okay. Very good question.
Am I audible?
Yes, you are.
Oh, then
am I audible?
Yeah. My external phone started working, so I'm testing.
So
effective. There are 2 questions he's asking.
Right.
Effective closed loops means automated correction using the data or manual corrections, stroke corrective actions. I think you already answered it indirectly.
I think, but this is a good question to reiterate.
The second question from him is, we have so many data from shop floor. Is it required to send and store all those data, or need to store only required data where corrections are required?
Let me take the second one separately, because these two are separate subjects.
Sure.
So let's go to the first question. Let's go back 25-30 years. We used to, when we were in the shop floor, 25 years ago, we used to have every evening or every midweek or every end of the week meetings with factory manager and all the shop floor leaders. Okay. And everybody had pieces of paper. What is stuck? There is an urgent order. Where is it stuck? That tool is missing. That tool is getting made either internally or outside. There was a big rejection. The 20% of what we made here, because of that particular dimension or that particular tolerance, got rejected, and it is getting reworked, or it is with salvage committee. These are the series of discussions that we used to have those days. Essentially, we are taking manual decisions on manual data, because data is being collected on pieces of paper from the shop floor managers, from engineers, from line managers, or whatever may be our line of business. Let's say now we have IoT. What is happening? The data is coming continuously to us automatically. But we may continue to take manual decision. But yet there is a gap. The gap is data is in a continuous flow of, figures, numbers. Unless there is a intelligent way of looking at it, which is what we call as analytics, either in the form of bar charts or pie charts or some kind of a graph. It doesn't tell us what is the complete perspective. For example, there's a very expensive, high-priced per hour, high-priced machine in my shop floor, and I've been asked by my CEO, track it. I want to make sure that whatever investment I have made, it is giving me good returns, and I'm tracking it. I'm tracking it on a piece of paper in an Excel sheet. That first hour, there was 200. Second hour, there were 250. Third hour, there were 150. Likewise. But if I put it in graph, I don't have to study the Excel. Imagine if there is an analytics which is giving me constant. So this is, I would say, intelligent way of treating the data, contextual data, presenting it in the form that it makes life easy for decision makers to make decisions. Now coming to your automated decisions, it is possible that with sufficient knowledge, with sufficient number of years data that has been converted to these kind of analytics over the years, it is showing me a pattern that in summers, in the afternoon, there is usually a drop in production because people go slow. Do I need to improve the air conditioning system? Do I need to change the food that we serve in the in the canteen? I don't know, whatever it may be. Or we can see that X supplier has about 20% rejection. Can we relook at the supplier? Can we relook at an alternative supplier? Or why is that this machine is giving us a lower utilization? Then we go find out that the person who's sitting is running a 50% override on the CNC machine rather than running on 100% when asked. And this is practical, sir. It has happened with me personally. इसको धीरे क्यों चला रहे हो? Why you're running it 50%? Oh, टूट जाएगा, tool टूट जाएगा. I don't understand. An engineer with sufficient knowledge has given a feed, speed, depth of cut in the program. Why is it being run on 50%? Because I'm fearful that the tool will break. That means either something is wrong with my programming or something is wrong with the training of the person. So these kinds of decisions, but automated decisions there afterwards would need to some kind of machine learning and AI. So the choice of making decision manual or automated is up to us. But the first half needs to get upgraded, where the data is collected live, acquired live, and then presented to us in the form that it gives us a certain amount of intelligence and knowledge rather than just data. That's the first half. Second question you asked was, could you remind me the second part?
We have so many data from shop floor.
Yes.
Is it required to send and store all those data?
Yeah, one of the trick is it cannot be data everywhere, nothing to use. Two. Okay, I'll bring back our doctor's report. How many line items does a doctor tell me when I go to him for 6-monthly checkup? 25? Kidney, liver, blood works, sugar. That 20, those 20 give him a sufficient understanding of my health. Exactly what we have to do for our shop floor. Those 20, 25, 30, 35, whatever it may be, hot points of data needs to get identified by us. This is what my business needs. These are the 25 data points I would prioritize myself. That's point one, answering your question. So you don't have to have data everywhere. But do we need to store everything? If your future is autonomous, if you're looking at some time in the future to adopt algorithms driving AI, it is important that we take all this data and store it in data lake, because which data will give me what kind of patterns and intelligence in the future may not be always known to me today. Think about it. Once the climate change becomes very important issue and you and me are asked, I want to understand what percentage of your product is recyclable. I cannot start that day. If I start doing today my data of how much chips were collected from all the machines, how many of these chips were sold. Chips means metal chips when you're cutting it, not electronic chips. How much oil was reused, how much water that came out was retreated, all these recyclable points, then only I would be able to generate a different kind of footprint for my workshop as compared to the way I used to work earlier. So we don't know what kind of data will be useful in the future. So idea is to store the data in data lake and slowly unravel the data lake based on how the businesses are changing. Did I answer that question?
Mr. Govardhan can put his thumbs up if he is happy. I am happy with the answers.
Thank you, sir. Any another question?
Yeah, one more question. Mr. Prakash, I think he's from Toyota.
Right,
He's
sir.
asking, he's our committee head for manufacturing.
Sir.
Is it necessary to have everything as data first, or first priorities what to have as data? Partly already answered. Yeah.
Yeah, but I think it is I think all the stakeholders sit together and actually, okay, I'll make a statement first. The biggest challenge is small and medium business segment, especially, not so much large companies like yourself, sir, because you have so many people who have been there, who have the institutional memory to bring in knowledge, to take that decision. The biggest challenge that an SMB has today is hesitancy of adoption of digital is not because of money, but because of the lack of this particular point that you make, lack of ability to identify where lies my gap in my processes. Adoption of technology is probably challenging, but the bigger challenge is the processes and the process re-engineering that has to accompany the adoption of digital technology. I cannot continue to lead my work in shop floor before and after the digital adoption. The digital adoption has to bring in a cultural change in the way so I think the answer to your question is not easy, sir. We have to sit together. Identifying the gap is first. Taking a leap of faith with a set of data is a starting point, but make sure we continue to audit it so that I can remove what is not useful and keep adding some more things which I did not consider at the first place. So it is also requiring a continuous improvement. Once upon a time, I'll again bring in the example of our medical checkups. We used to do pre fasting sugar and post breakfast sugar, whatever, post eating sugar. H1B came later, where it said that it gives us a number that what is the average sugar content in our blood for last 3 months, and it gives me a time test, time based measurement rather than only that day's measurement. So similar thing, H1B was not there 20 years ago, 25 years ago. Same thing. I think we should start with the basic set of data that we believe is important and then keep correcting it. Any other questions, sir? You're muted. For some reason, I'm not getting. Yeah.
Another one just now popped up.
Yeah.
Which I thought we can take up at the end also. What are the skills and talents required for SME sector, employees and owners to adopt the digitalization?
What I would do is I will hold this question, sir,
Correct.
because I'm showing the example, and I think some of it will get highlighted when I go through the example. Okay.
Correct.
So I'm going to allow me to just choose the next presentation. I've got two sets, so. So I call it realizing next. Can you see my screen?
Yes, yes.
So this is a very interesting one. Why did I say next? One of our CEOs used this word called next. He said, there is no best practices at this moment. Because whatever we used to do for last 50 years, 30 years, 20 years, whatever we learned is changing. So let's not call it best practices. Best practices, the concept is let's call it next practices. Okay, so that's why I used the word realizing next. What should be the next practices? Because we are all evolving in the new doing things. What do we realize? We just established product digital twin, virtual product. We need to have a production digital twin where I will continuously verify and closed loop so that whatever I manufacture is what I designed. And then after physical production, I supply, and whatever is happening in the performance on the either on the shop floor for machine, remember the two layers, or on the product when I supply to the customer gives me a continuous feedback. So let me change the pointer. So this is the production performance. This is the asset performance with the customer. So these are the two measurements, and it gives me continuous feedback either for design optimization or process optimization. This is the crux of what we established in last 1 hour. Okay, now we will take a real life example, and I'm sure there will be many interesting observations. That's the whole thing. Idea is to discuss it. Let's take this as a real life example. Now this is a product, this is a truck, and the question that comes is, how do we extend the range of our trucks to fend off competitive challenge? This is not an automotive problem. I'm not going that far. This is an small and medium business segment, a supplier, because the route that I have chosen to explain this, demonstrate it to you, is that I will say, okay, I need to probably whatever I want to use digitalization for a rapid response to this question, innovation requirement that I need to extend the range of the truck, but I have decided I want to make the petrol tank or diesel tank bigger. That's the idea. That's my answer to this question. Okay, let's take that as a simple solution for this innovation. What is the impact of modifying the size of the fuel tank? That's the first question that comes to my mind. Did we not make a truck 30 years ago? Of course we did. Did we not go to moon in 1969 when hardly any of these IIoT or internet or any of these things were available? We went to the moon. Sorry. Yeah, just keep yourself muted, sir. Okay, so what's so great about it today? The challenge that we have is because we don't have that kind of time anymore. Anybody who's taking more time will lose market share, will lose competition, will not be able to establish himself in the marketplace. So we have to be quick, number one. Number two, we have to ensure that whatever we are doing it better than what we did before, in terms of energy consumption, in terms of material consumption, in terms of making it lighter, in terms of using alternative material, using operations which are more efficient than before. Now, if we have to analyze the impact of modifying the size of the fuel tank, and I have a digital solution that helps me to do that, it will probably look like this when I have a complete vehicle system, or at least the tank system, even if I'm an SMB, which says what are the various things that go into assembling a larger petrol tank or fuel tank. It needs straps to hang, it needs some sensors, it needs some tubes to pipes to take the fuel. It needs a fuel pump connection, etc., etc. So that is what my first impact analysis shows, that the blue box, it shows all those filter cap, fuel tank support, fuel tank lines, chassis support, chassis hangers. These are the boxes that are getting impacted because of the size of the fuel tank. Let's move forward. Let's assess how much extra load because of the larger and therefore heavier tank affects the brackets. So I have what we call it, some kind of a configuration diagram here, which is how I do my FMEA. And I do an FMEA on this. I essentially analyze what is the result of a larger load. The larger load result would be a fractured, let's say, a bracket. So I need to redesign the bracket. Okay, let's find components affected by change in the fuel tank. Now I'm going to go one by one. So I ask my digital system to give me anything in the proximity of the fuel tank, show it to me. Okay, I see I have a strap. What am I doing? What am I doing right now? I am experimenting. I'm experimenting with my changes. How did we do it earlier? We did it physically, actually using a physical truck and a physical tank. It used to take a lot of time. I'm saving time. Then I'm going to try out certain experiments and alternatives. In the past, we used to do with prototypes. Now I would be doing virtual prototyping. Let's move forward. Let's see how it works. So now I'm going to modify the size of the straps. I'm going to change the size of the tank. I'm going to change the position of the fuel pipes, and all these have to happen quickly. I'm reusing my old knowledge. I'm reusing my engineering data, and I'm comparing the three models to tell me how my decision of taking a larger fuel tank is impacting the geometry around it. It doesn't end. How do I know the decision that I've taken is right? I simulate structural, I simulate computational fluid dynamics, because larger tank also means sloshing of fuels. It means the entire dynamics and the load on the chassis bracket is going to change. And I simulate it to check what kind of dynamics it would apply both on the bracket or on the chassis. It doesn't end there. We decided that we will reuse our past knowledge. So I'm searching in the library. It's like a Google search for shape. What is the closest that I have from past, which will give me this new strap? So I found one and I reused it. I take the same strap and maybe change it by dimension because the thickness of the metal or whatever else I need to do. This gives me these changes. It gives me three things. One, I'm reusing, so it is taking less time. Number two, I'm experimenting, so I'm innovating. Every time I experiment with multiple alternatives, it allows me to do some innovation and I optimize. Okay, I move forward. It doesn't end. This new design would now require, do I need a new layout for making this tank on my shop floor, or I take an existing line and change it? So I go and study, where will I make it? Let me make a new line because I already have other lines. I'll make a new line for this larger tank. If I get this insight upfront, all these costs are built into my bid. What is the biggest challenge for a supplier? Doesn't matter, supplier in automotive, supplier in motors or generators or machine tools, doesn't matter. It requires a bidding process. It requires estimating the price, the cost which you're going to quote. If you bid very aggressively, we may not make margins. If we bid safely, we may not win the order. So it has to be balanced between the two. Ideally, we should be able to do such experiments virtually, such simulations virtually, and assess what kind of infrastructure changes, in addition to the change in tooling, in addition to the change in the manufacturing operations, what are the additional infrastructure changes that I need? What kind of changes does it require in terms of man handling? Do I require 2 people? What kind of lower back pressure would have? What kind of gantries and clamping system do I need? All these can be simulated now in advance. Okay, I'm now experimenting with operation. Remember, Molly made a very interesting observation. Production has always been our challenge. Design, we have really done well over the last 20, 25 years. We have digitalized it. We have experienced it. But the bottleneck has moved. Bottleneck has gone to the shop floor. And we have to give equal credibility and importance to shop floor now. And that's what we are looking at. The new work instructions need to be generated, which are integrated to the challenges have probably reduced with time. I'm giving you a story. My first job after engineering, my first year of the job, I was a trainee in CNC machine shop. And we had a huge rejection. And the reason of rejection was the drawing was different from the process plan, was different from the program that was loaded on CNC. We cannot afford such kind of. I am given to understand even now in SMD, we do have that kind of challenge. The drawing is not, either drawing is the latest, process plan is still the old with hand changed, instructions, and probably the program that is loaded on CNC is changed daily by whoever is the manager there to the convenience of what tools are available and change in sequence, whatever. Sorry, something happened. I was thrown out. I apologize. Can you see my screen?
Visible, sir.
And you can hear my voice, yeah, of
Yes,
course.
sir. Clear, sir.
Okay, so I was at electronic work instructions and keeping it latest, and I was giving you a real life example from, of course, 20 years ago, but I don't think these problems have gone away. Now, imagine there is probably a need of new automation as well, because the proximity switch needs to change position. Probably it needs to change itself because the size of the tank and the configuration of the tank has changed. I may have to change the automation controls. That too is integrated. So we just saw something. We had a new order from customer. We decided that we will change the size of the tank. We assessed what kind of impact that change in the tank size would have on the brackets. We chose the bracket from past data. We modified it. We validated it. We came and revalidated the shop floor changes, the material handling changes, the impact on people, the work instruction, and automation and the PLC programs or whatever else we may need. That's not complete the task that we have to do. Imagine now we have to bring in this new tank, means it has to fit into the existing schedule. So I have to run the new scheduling. Once that is done, here, watch this. What is going on? Where am I wrong? I went ahead. Sorry. So this is where I actually start manufacturing on the shop floor. And whatever I'm doing, there is a feedback. There is constant data acquisition. And once I continue to collect the data, I start comparing with what I planned. So the IoT data helps me to give me a pattern of what is happening with the fuel tank on the truck? Can I now measure the vibration? Can I take feedback and compare it with what I estimated in my simulated results? Is there any breach? Is there any break? If there is a break, what is the reason and how can I prevent it? Do I need to change? And if I need to modify the design, what kind of changes do I need? And I redo my analysis to figure out, okay, my bracket is breaking, my hanger is breaking because of additional vibration from actual product being supplied to the customer. Let me go and validate it. So this completes the entire story, and this is a story of continuous improvement from shop floor to customer. I will stop here and we will have some more questions. Before, I have some case studies which I would share, some 3-4 examples in brief. But before that, any questions? We have about half an hour with us. And I would say that we should have these questions along with the case studies, because some of the answers can happen. There was a question that I asked you to hold, Molly, which was to do with skills, right?
Yeah.
So now you can put this one into perspective. If we have to have skilling requirement, either with our existing people or with the new people that we plan to, take, we should be looking at how are they going to help us for digital product definition? How are they going to help us with digital production? How are they going to help us in IoT and real production data acquisition? And how are they going to help us in servicing customers today with continuous improvement? I know it's a big ask, but I think time has come. We have to realize that unlearning and relearning is a reality of today. As much as for me, as much as for you, as much as for people who work for us. Unless we are able to unlearn and relearn, it will be a challenge for the organization to deliver to our customers what they are looking for. And if it is not us, somebody else will do this. Does that answer the question, sir, on skilling?
Partially, yes. But maybe I can help you out since I'm doing a lot of work in the
Sure.
skill area.
Sure, sir.
Now
Please
or
go
later,
ahead.
maybe I can touch upon
No,
now.
go ahead now. Yeah, because it's relevant now. Go ahead, sir.
See, the question that gentleman asked, not Govardhan. Let me see the name. Rajendra Krishna Prasad is what are the unlearning, learning? Yes. But what are the specific skills which are required and talents required to SME sector? I think one of the major aspects of skilling is it is not possible to have captive resources in the small and medium enterprises. To ask for a factory automation engineer or a digital manufacturing engineer or smart mechatronics engineer, or for that matter, a cloud computing engineer or a cyber security engineer acquired and hired in a small and medium enterprise means too much on the table in terms of the hiring cost. So obviously the employees and owners, as far as the owners are concerned, they should be exposed to the purpose of digitalization, the awareness creation, the return on investment, and the benefits which are accruing in terms of the value, in terms of quality, delivery, cost, flexibility, efficiency, energy, and so on and so forth. That much about awareness and buy-in is required for owners. A deeper training may not be required at the owner level. At the employee level, in my opinion, I think Gautam can definitely add value, is the human machine interface, the HMI. Training is extremely important. Even in SME, you need to have the digital devices, the interactive devices, maybe a tablet, maybe an iPhone, maybe a handheld terminal, whatever it is. And once you computerize the environment, there is no escape from the human-machine interface. I think the HMI is the most important training. I have seen this happening in Tafe Dudabelapur. Not now, I'm talking about 8 years back. When a team of people visited Tafe, all the employees at the shop floor have been trained on operating the tablet and drawing data and sometimes even giving instructions. There is an interactive approach there. It is not only a one-way traffic. There is a closed loop to the extent there are some instructions being given. Manually driven closed loop, not autonomous.
I agree. We can start with that. Even that is beneficial than that.
Yes. So that is one skill development. The other skill development, Gautam, which I seen in a dying need, a crying need in SME, is maintaining the IoTs and other devices which have been implemented on the shop floor. So to the extent that the commissioning is already done by an expert coming from outside, but thereafter maintaining them. When I went to one medium enterprise, not small enterprise, a 200 crore company in Chennai, a couple of years back, they are very keen to implement. They are a sub-supplier of Tafe, coincidence. And in one of the 10 cells, Tafe implemented IoT. But sadly, I found when I went to the line and asked the operator, hey, kya hai and all, so pata nahi sab, wo laga ke chale gaya. So, that's a very sad state of affairs. Even the pilot study done by their own OEM to the tier 1 supplier making clutch brakes, because of the criticism, I'm not mentioning the company name, is not maintained, quote unquote, properly. So I think little championship has to be developed at the supervisory level, if not at the operator level, on the manager level of the shop floor, to maintain the pilot study. If pilot study is not successful, how will Tafe do it in the other 10 cells? Of course, all cells don't belong to Tafe. The clutch brakes made for Tafe was in that cell, and another cell was meant for another tractor company. All the clutch brakes were tractor company. So I think, and therefore I think a very important thing, even from the designer perspective, say Siemens or Schneider or PTC, etc., when they implement, or the new system integrators who are emerging now, is to make simple solutions which can be commissioned and maintained. Not only make it affordable, so the owners are happy to implement, but also make them as appropriate and simple. And these are many, many experiments which are going on now. And the third last point is cloud computing and cybersecurity. Obviously, they cannot afford it. So subscription model is there, and they have to believe that it is secure. When the OEM is telling Baba, cloud computing is secure. For example, I think our Mr. Devarajan and Prakash are listening to you. They know that when they want to develop their tier 1 and tier 2 supplier, the cloud will be made secure by TVS Motor and Toyota, as the case may be. And then the benefits have to automatically accrue to the tier 1, tier 2 suppliers who are doing a subscription model on the cloud. The dream which I have been proposing is hub and spoke model. So there is no skill development required for the SME. That's the point I'm making. So I think we need to simplify. We have to rather de-skill. Rather than implementing skills, we should de-skill the requirements of the SME. Mr. Rajendra, I hope partially I answered your question. We will have a separate session, 2-hour webinar, where we will bring the people from the skilling domain.
Because what you say is right. From shop floor perspective, probably we have to de-skill and make it more intuitive. But from the preparatory point of view,
Yes.
when you have to make the design, make the process plan, that part I don't think we can avoid de-skilling. We have to have people who know how to make CAD design, who can make CAM and process plans and tooling plans, etc.
Agreed. Absolutely
But
right.
as you said,
The point I'm making there
yeah,
is that when most of the 85% of the Indian manufacturing, fortunately or unfortunately, is automotive driven, and I think it's slowly coming down to 75%. There, they are only building to print or building to somebody else's design. And when the design is coming from the OEMs, like Tata, Toyota, Tafe, or whatever, then very little is done even at tier 1 level. I think CAD-CAM is also doesn't exist in most of the tier 1, and definitely not in tier 2 and job shops. So I think the simple aspects of skilling, the one foundational requirement is computerization. If computerization and the removal of paperwork is not done, even in the smallest of the enterprise, this project will not succeed. So I think enough skill has to be brought in the computerization, in the interface to the computerization, like the HMI, to some extent the PLC, which are connecting all the equipments and all, to maintain them. And if CAD/CAM exists, yes, of course, the complete digital training on how to design and then manufacture, how to come. This is restricted to the tier 1 and OEM.
I would like to add
Yes,
your
sir.
point is baby steps.
Baby steps.
There is nothing called big bang, baby steps. So let's say, like you said, if I am designing, if I'm building to print, I don't need CAD. I don't need a design digitalization. But if I am designing, even if I'm modifying, I need to have some capability to run some experiments to decide. I tried 5 different alternatives. I decided on one by doing these experiments. That is a basic capability we need to have as far as designing is
Agreed.
concerned.
True.
When we go to if I am manufacturing, if I'm, let's say I have 3 CNC machines and I do, I take parts, design from inputs from my customer, and I deliver uh, batches of completed components to them. I need to know programming because there'll be design change tomorrow. There'll be design change while I am on the job. I should be able to quickly adapt to the new design and say, okay, that would be my strategy. That would be, there is a thin wall. How do I make sure that my manufacturing process in CNC doesn't damage the thin wall? What should be my strategy? These are the stuff alternatives. Then there is fixture strategy, then there is tooling strategy, and these strategies would need digital knowledge of how to do CAM. If I'm doing process planning tomorrow, I have an assembly shop, I have 10 workstations, I have to improve the takt time. Should I complete the job in 10 workstations or should I have it in 8 workstations? How do I do load balancing? It will take me 5 years if I have to do manually.
Absolutely.
And if we believe that more and more the batch size will reduce, diversity of products and components and subsystems will increase, these tasks will become a daily task.
Correct.
Then it becomes a challenge.
No, I think to rephrase what you're saying, Gautam, the job of manufacturing engineer, which is today becoming a digitally enabled manufacturing engineer, is a need even at the SME sector, without doubt. The shop floor operator may have the fundamental knowledge like programming, etc. Totally. Inspection, programming, and jigs and fixtures, etc. But the manufacturing engineer job is becoming very important. The salaries paid to them are much more than the normal engineers. So SMEs should wake up to this reality that they cannot invest nothing and get the benefits of the digital. So I totally agree with you that there are some job roles, existing job roles to be acquired, and then they have to be upgraded to digitally enabled job roles, even in the SME sector, without doubt.
And you are right. I mean, cloud-based subscription has made it easy for acquisition of technology. I am a firm believer. Technology is an enabler only. It's all the human people who have to actually execute it. You can buy the best technology and yet not deliver. Okay, sir. Let's take the examples.
2-3 questions have come, but we should take it up. They're a very important question. We should take up at the end.
Sure, sir. So I thought we'll take some customer examples from large to big to small, just to give you an example of how JCB is doing engineering with 50 to 60 product updates a year involving 200,000 variations. Now, this is a very large company, of course, not the best example for SMB, but just to give you an example of how shape search. Remember that example of how I searched for the bracket in my company to figure out what I had. They did 600% of BOM improvement for all configurations by doing these kind of searches and reusing of past data. And that's huge. Okay. This is another very interesting example. This is an SMB example. It makes, they bid, this is a control arm project. They used to take a lot of time for designing, simulation, and then optimizing it based on the customer specification. So what they did was they developed a optimization system, a program with which using leveraging CAD and simulation, they could simulate 1200 more designs automatically in an 89% faster process and developed a 31% lighter part based on fatigue targets and nonlinear and linear structural integrity targets. Imagine if you can reduce the time from 27 weeks to 3 weeks. This is a Siemens own example. As you know, we do manufacturing ourselves. This is a geared motor factory in Germany. Essentially, this is a very interesting example. Simulating the entire machining sequence and the workflow and the material flow. They reduced the BOM, faster lead time, and flexible production because they were being now more designs and more diverse designs were coming for manufacturing. So based on the order quantity, based on the flow sequence of operation, they simulated the entire shop floor. This is not a very big factory. It can be compared to a small and medium. They just make these boxes as you can see in the picture. This is a design example. This was a restricted space electric car, and essentially for optimal climate comfort of people. And they did experiments on the virtual product to develop what should be the duct design. And obviously, it is very, very, I would say, shapeless. It's more amorphous because it had to fit into the body of the car. They did 400% improvement in demisting because that was a challenge. They used to get mist with 3 people sitting on the window panes, and they reduced potential cost. This is an Indian example of Ashok Leyland to generate reliable production plans to maximize demand allocation and capacity utilization. So they had constraints on multiple demand orders for different area offices, many configurations of vehicle, about 6 assembly lines across 4 plants. The idea was how do they maximize capacity and minimize logistic issues. So they developed actually a simulation-based optimization. As you can see, it's called MPS Optimizer. I haven't seen it practically, but I'm sure some people would have. 75% reduction in outward logistics, 8-hour to 1-hour response reduction on demand changes, and of course, reduced inventory. Another Siemens example, our own component factories. This is electronics sub-assembly. Very high degree of product variance, small lot sizes. This is typically the modern day problem. That's why I included that as an example. Smaller lot sizes, fluctuating order volume, especially post-COVID, when your demand and supply side, both sides are unstable. Everything changes on a daily basis. They could use the solutions that I shared, especially on simulation of work allocation, simulation of batch size variation and the sequencing, to create a digital model of the plant to simulate the entire production area. And they had 100% improvement for all three aspects of time, waste, and quality. This is an example from Case New Holland. To improve production efficiency and product quality for multiple products, a similar problem as the previous one, except that this is a very large product, complex one. Essentially streamlining the work instruction. Whoever creates the instruction, that's called authoring, and multi-product line balancing across all plants. And they improved 40% on engineering time. This is something which I would like to, we have a global relationship with HP for 3D printing. This has been another area where a lot of interest has been shown, but we haven't yet understood. I'm talking production 3D printing, not for prototyping stuff. HP makes 100% of their parts that go into printer in 3D printing production. I'll repeat, for 100% of their plastic parts in HP printers, they are 3D printed in a production environment. And they also make the such 3D printers which are 20,000, 30,000 parts a day. So essentially there's a challenge. The challenge was, how do we improve the cooling? Because without cooling, you cannot achieve such high speed production of 20, 30,000 a day. As you can see, the cooling was improved by changing the manifold, which is there on the left hand side. This is how it was, and this is how it became, with a small tongue in between to improve the vortex flow and improving the cooling. So if you see, this is how improvement happened. So you reimagine the product, and then you go through the entire loop for designing, redesigning, and optimal designing. So leveraging the entire digital thread from additive manufacturing, design, simulation, and 3D printing. So my point I tried to make here is that 3D printing is less about 3D printing, more about design. We have to look at design. The more complex the design, the more economical is 3D printing, because you cannot probably have a tool. You cannot possibly have a tool for this manifold, as you can see. It cannot, it is probably impossible. Whereas a standard injection molding tool can produce a manifold like this. This would require to be 3D printed, but then these are the kind of improvements it has. So I would think that we should take those questions, because we are just 14 minutes short of 1 o'clock.
Okay, Gautam, I think fantastic examples that would have got some flavor to the audience. I think we had a very good perspective of the challenges, the 5 challenges that you mentioned in digitalization, and the possible solutions. Thank you very much for giving an overall perspective of this topic. This itself can lead to several other masterclasses in the days and months to come. Let us move on to the. Absolutely.
Yes, sir.
Question. I would like Rajendra to put up his hand and ask himself, because his question is valid for many companies.
Yeah.
Namely, what are the steps needed to follow and plan? Go ahead, Mr. Rajendra. Which company you are from? Yes, Mr. Rajendra, you can ask.
Hello?
You can ask which company you are from.
Yeah, I'm working right now from my own company, PRK Engineering Consultant Services in Hyderabad. I'm retired from Voltas earlier. Okay. And I happen to be MTech in production engineering and MBA. And I'm presently also a committee convener for Hyderabad Management Association MSME committee. So I happen to meet a lot of manufacturers in defense components making and automobile components making. So I come across a lot of their queries as such, So now the happening is smart manufacturing, how to the implement.
Go ahead
Government
with
is
the
giving,
question, sir. We have very little time. Go ahead with the question, sir, if you
yeah,
don't mind.
fine. Yeah, fine. Yeah, my focus area is earlier we have ISO 9000 certification for small industries, big industries and all. There are a lot of in between people who have come and find the industries and given certification. And second revolution has come ERP package for integrating all the information and have a communication network. So that is also happened for small industries, big industries, large industries. Now the trend is on the smart manufacturing, where a lot of internet-based IoTs and cloud manufacturing and a lot of information.
What is the
It's
question,
only
sir?
from the
I'm still waiting for the question.
How we have to implement this in SME sector to change the mindset of the entrepreneurs, and then so that they can invest it and take a risk, and they can have a clarity in Tier 2 and Tier 3 industries. Yeah.
Okay. Your question is on change of mindset, so I'll first attempt that. Why do you think they adopted ISO 9000 or whatever else 15 years ago? Do you remember?
Yeah, one is for branding, other is for systemization. Yeah,
I remember. No, there was one clear set. If you don't have the certification, you cannot be my supplier.
You're right.
Okay?
You're right.
Same way, when ERP got implemented, ERP started from the finance end, because unless you create your book of accounts within X number of days after the end of financial year, you would have serious penalties. And few of the ERP systems were certified by authorities saying that if you have an output from a system like this, we accept it. Okay, till then it was probably managed by hand, the books. So there was, all these changes have happened because of certain market pressures. That's the point I'm trying to make. The same market pressure today is coming in, where when you have to quote anything, people ask, on what basis are you quoting? And number two question they ask, how do I get confidence if I place an order on you that you will be able to deliver what I'm asking for within the time, in cost, as per the quality that I demand? Unless there is a demonstration, it cannot be in words. Trust me, believe me, sir, I'm very sincere. It won't work. We have to demonstrate. The only way to demonstrate is by using virtual simulation, digital ways. This is how I would design. This is how I would make change. This is how I'll make it transparent. You would be able to see my project. The answer is similar to what happened in ISO 9000 and what happened in ERP. And that's how the mindset would change. Point I'm trying to make, if we don't get it, we won't get the business.
Yeah. Fantastic.
Yeah. I think you're right, absolute right.
That is one way of opening the mindset. Yeah. Fantastic thing. It's a breakthrough mindset. And I would like to add, Gautam, the second area of mindset opening is what is in it for me in terms of the benefit.
Yeah,
correct.
The rework today, the rework still happening from medium and small enterprises. They might say 50 ppm to the customer. The customer interface ppm is 50 ppm. I have seen the Hyundai suppliers bragging saying we are achieved 50 ppm. When you go to the chamber and ask the owner, sir, what is the ppm internal to your factory before it is delivered to Hyundai? Then they smile and say it is 1000 ppm. Right? The truth is known to us that it could be even higher than 1000 ppm in some cases. Lot of filtering happens, lot of sorting, and the good product goes to the end customer. The cost of quality is humongous even today, after 4 decades of industrialization in India. I'm not saying 7 decades because I'm counting only from Maruti Suzuki days. Ambassador and all can forget about it. So the cost of quality measurement is a one single factor to open the mindset of the MSMEs. And who will open the mindset of the MSMEs? The OEMs. The OEMs, respective OEMs, have to play a large role.
Yeah.
Rather than consultants like you or anybody else trying to struggle to open the mindset.
You're right.
Yep.
Yeah.
Yep.
So that will primarily come from quality and the rework thereof. Secondarily, productivity and efficiency. And thirdly, condition monitoring and uptime of assets. In that order, I'm mentioning to you.
Absolutely, sir. We
Please.
sometimes forget most of these companies and organizations and investors, CEOs, they use OEE as a measure of improvement, right? Overall equipment effectiveness or whatever it's called. Yeah. What is it? It's equal to, essentially, I just wrote it down so that I don't forget, is performance multiplied by quality multiplied by availability.
Perfect.
Correct? Correct, sir? Now think through. This is math. Imagine if all three are 90%.
Yep.
Very good. You think it is good? Multiply 0.9 by 0.9 into 0.9.
72%.
It's 72%.
So poor.
So it is that bad. Yes. So unless you are 98, 99%, you cannot imagine your OE to be, attractive. So this is a realization we have to understand. It's not, you're right. When I supply to the customer, I may give all polished, but how much effort did I make back end? You're absolutely right. Probably 30 hours of hand cleaning and deburring or whatever else I do, making sure that the positioning tolerance and the dimensional tolerance are all done. So that is something which we have to see. Actually, how much money and how much time I'm spending on delivering to the customer requirement. Absolutely.
Great. Now, next question. Prakash Ji is asking from Toyota, is there any international standards for Industry 4.0 to ease up and speed up the interfacing among many elements?
Very,
like
very good
ISO.
question. This is extremely interesting question. This is very matured question, sir. Firstly, internationally they are. See, because this initiative had different names. In Germany, it was Industry 4.0. In France, something else. In America and Japan, primarily. Germany did come out with the RAMI standards, RAMI. You can have a check on the web. But it's not necessary that what Germany did is the same. Let me share something with you. Molly knows, as part of the CII work, we know BIS is developing standards for Industry 4.0 in India. So this is there is a committee which is building, and they're doing very good job. If you are interested, maybe you can reach out to BIS directly through Ministry of Consumer Affairs, who own that function, and they are actually developing. So you would see more and more these things figuring in government policies and stuff, and things are happening. To answer your question, yes, India is developing its standards. With 5G, probably it will coincide, because we require suitable bandwidth independence if we have to go all out on IoT. 4G is already, not very efficient.
I also have some literature on ISO 9000 for Industry 4.0. I will share with Prakash.
Yeah. Okay. Thank you, sir.
Good. So, coming back to questions. Yeah, Mr. Jinesh is asking a very important question. Jinesh, you are from which company, sir? You can ask yourself. Let that be the last question for the day. Mr. Jinesh. Maybe he asked and left. Okay. So many times the real value addition, return on investment, is visible only when the digitalization is completely implemented in all the departments. For an SME decision maker, how to overcome this challenge to make a decision initially whether to go ahead or not?
Very, 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 very interesting. I would say it is for us to do the measurement of improvement. It has to be done in baby steps. It's very challenging otherwise for multiple years or multiple quarters of implementation and draining of money without an investor seeing any value or return on investment. So it is we should, as I said, baby steps means start with, and it was very heartening to see your report where NASSCOM says that many of them have started IoT. The, the easiest, we all know, we take daily decisions in factories. If I can get data in an interpretable form, in intelligent form, and that helps me in reducing the decision making time and makes it more accurate, immediately there is an ROI. So I think we can start with that. But then once we have the data, we have to take decision. Decision has to be in design. Decision has to be in manufacturing. Decision has to be in quality or in logistics, in supply chain. So we may create these multiple small projects with KPIs in every project. And that's how we can demonstrate to investors and CEO and the management that, see, you gave me this money, I implemented IoT, now I'm getting data, I'm sharing it with you, you are able to take quicker decisions, more accurate decision. Last year we took average 35 days to take a decision. This year we are taking 11 days to take a decision, like that. These are improvements.
Another point I would like to add, Gautam, to Jinesh, is that while you can make a mega plan for the entire organization, for, as you said, completely implementing in all the departments without silos, the plan itself is executed in baby steps, as Gautam mentioned. And for each baby step, you can define a benefit measurement. You can measure baby steps measurement functionally or overall KPI for the organization, and then start investing. You don't have to commit the total investment in the beginning. There are methods of doing it. Okay, we will move on to the last question. Mr. Bhushan says he missed. I'm sorry, Mr. Bhushan. We all have to start and end at the right time and this thing. But I'm happy to inform you that Bangalore Chamber of Commerce will take the permission of Gautam and see whether the YouTube video can be published. That Rupa will write to Gautam. So then, but next time around, please join on time, right? Many of you joined up to 12 o'clock. I kept admitting, not an issue. Mr. Ravi Gaudara, last question. Gautam, then we'll close.
Sir.
I had to rush to Chennai after this. He says a very philosophical question. Just a corollary. Insurance has increased the cost of living. Thus, I 4.0 increases cost of product, if not deployed holistically.
Now, I see that question. I understand that question. Let's change that word to value, and then you would see it differently instead of cost. Let's say insurance has improved the value of our lives. Let's call it Industry 4.0 improves the value of our products.
Perfect.
It's not cost anymore. When I'm going to buy a machine, sir, tomorrow, I'm going to not ask you which is the lowest price machine. I'm going to say which machine will give me the lowest running cost for next 10 years. And when the question is asked like that, immediate question would be, how do I commit to that? You cannot commit to it unless you're digitalized. You're able to take the IoT data and do preemptive maintenance. And you're going to keep the knowledge of that with yourself so that you can reuse it for other machine 2, machine 3, customer 2, customer 3. And that's what will start giving you better returns. So it's about value. It's no more about cost.
Perfect. Superb answer. Additional answer to Ravi Gaudara. There is a famous proverb or slogan, or what do you call it, jingle in ICICI Insurance. They say, Jeete Raho. Yeah? ICICI Insurance says, because you have taken insurance, you don't have the fear of losing your life. Therefore, your life goes up. So, Jeete Raho. Such a clever kind of an advertisement by ICICI in the good old days. I think they still continue the same ad. I don't know. So, I think the point is insurance cost is a minuscule 0.25%. Whether it is a life insurance or whether it is a medical insurance or whether a vehicle insurance, etc., etc. The cost of prevention is always 1,000th of the cost of failure. It is proved in automobile industry. It is proved in aerospace industry. You know the story of Boeing 777 MAX. Just a battery, 12-volt battery, and a small IoT sensor, which opens a flap on the tailwind, is the cause of the 3 aeroplanes which fell down in the various parts of the world. So I think the cost of prevention is the insurance. So never worry about cost of insurance. It is the hidden cost of manufacturing, the hidden cost of product failure, the hidden cost of lost customers, and the hidden cost of losing your entire business for a small and medium enterprises is much more, probably 10,000 times the cost of the IoT that you're going to implement. My good friend Jagannath shares with me, it ranges between 0.5% to 3% of the turnover of a company, inversely related, depending upon the turnover of the company, is a cost to be incurred on the basic Industry 4.0 solutions. So therefore, I think the cost is a very small percentage of the benefits and the value that you're going to derive. That is another perspective I wanted to share.
Thank you.
On that note, I thank you, Gautam. I think we are moving from, Prakashji well summarized, that shifting from cost to value is a great thing. Value competitiveness rather than cost competitiveness. Thank you, Prakash, for further insights on the point of value. That is why it is called the value chain rather than the cost chain. And I think the final value is derived by the OEM like Toyota. And therefore, we have to guide the small and medium enterprises. If a consultant directly goes and try to convince tier 1, tier 2, tier 3 company, more often than not, he comes back only with a cup of coffee, without a purchase order, or not even a POC trial of the IoT. And I know this for a fact, the Indian experts in IoT are getting business from Middle East, getting business from UK, getting business from America, getting business from Singapore, sitting in India in places like Coimbatore. They are minting a turnover from other parts of the world. Very sad story. That please wake up Indian industry, even the small and medium enterprises. Thank you very much. On that note, Mr. Gautam, any last word from your side, sir?
No, thank you, sir. I think you summarized it well, but you're right. I think we should go deeper. Maybe we take separate subject matters and go deeper there. It will be interesting, and learning would be for all of us.
In fact, I wanted to request you, if you remember the original topic we planned and changed, I think you started rightly with the challenging aspect. Now the next topic we'll take maybe within the couple of months is how do we measure the benefits and the value and the return on investment, be it a OEM or a tier 1 or a tier 2 or tier 3. And the exact workshop that I attended in your Siemens workshop 5 years back, 7 years back, and those kind of, and your additional knowledge that you got with focused on companies below the 500 crore turnover,
sure,
to as low as 5 crore turnover,
sure,
will be our focus of next time. Thank you very much, Mr. Gautam.
Thank you, sir.
Thank you, Rupa. Thank you, all the audience. I think we had fantastic profile of audience today. The numbers are 50, but all of them come from very, very reputed companies. Later on, we'll share you with the registered participants, and they may ask you some direct questions. If you don't mind, you can type your email there.
It's here.
In the box.
Yeah, I have it here.
So that some of them it's there, and some of them make a note. And I know that there are some more case studies and use cases Gautam has. He will share with us in the future. This is a series of masterclass webinars on behalf of Bangalore Chamber of Industry and Commerce, which will go on for the next 1 year or so, and then probably there beyond also. And thanks to the remote virtual MS Teams, we are able to share it with a larger audience and take permission of Gautam later to see whether this kind of a recorded session. See, any amount of slides which you see, you can't understand unless Gautam explained the way he explained. He is a true emerging teacher for the digital manufacturing ecology in India. And I wish him all the best to get his PhD soon.
Thank you,
and
sir.
Become
With
a
your
trainer
blessings.
and teacher for as many companies as possible in this country and beyond. Thank you very much, sir.
Thank you, sir. Thank you.
Best wishes to all of us. Thank you.
Thank you very much, sir.
Thank you, Rupa.